Hello friends! Some of you asked me to make a video about the CPU and GPU undervolting. On YouTube we already have a lot of videos dedicated to this topic, and I began thinking about what new I can bring to the subject. Most of these videos told us that undervolting can reduce noise, increase performance and battery life. But it's not always true. Today we will only talk about the CPU undervolting on Intel-based laptops. But this information can be also used for the desktops as well. It's not a guide of how undervolting your particular CPU. No, in this video I will try explain you a complex process in simple words, giving the minimum necessary set of information that will allow you to understand what are you doing and predict what result you will get in the end. So, after this video you will have a solid understanding of what undervolting is and how you can apply these techniques to your particular case. A bit of theory. You should always start by looking through the official CPU specification. In reality, the topic is much more complex, but without going into the detail, there are three main CPU characteristics that we are interested in. Thermal design power, or TDP, represents the average power in watts the processor dissipates when operating at base frequency with all cores active under an Intel-defined high-complexity workload. In microelectronics, it's generally accepted that the amount of energy consumed is equal to the amount of heat produced. So, if the CPU consumes 45 watts of power, your thermal solution should dissipate 45 watts of heat. Processor base frequency usually represents a maximum CPU frequency granted by Intel in multi-core mode and full CPU load, without exceeding the base TDP. And the last one is max turbo frequency. Generally, it's different for single-core and multi-core mode. It represents a maximum frequency the CPU can achieve when certain conditions are met. For example, your CPU should not go beyond the TDP, thermal and power consumption limits. Why the same CPU works differently in different laptops? There are two main reasons. The first is simple. Base CPU specification can be modified by the vendor, I mean your laptop manufacturer, and also throttling, that can affect your CPU performance in order to reduce heat and power consumption. We have three major types of throttling. Power throttling represents a situation when your CPU temperature is below its limit, and in order to reach its maximum frequency, CPU wants to consume more energy than power supply can provide. Thermal throttling is when your CPU has reached its temperature limit, staying below its power consumption limit. And the last one is when we have these both types of throttling together. And what is the undervolting? Technically, undervolting is the reduction of the CPU operating voltage in order to reduce power consumption. As I explained before, lower energy consumption contributes to lower heat production and lower current TDP. This allows the CPU to achieve a higher frequency and performance without exceeding the limits. Just for conclusion, your real-world CPU behavior depends on the vendor configuration and, on the other hand, on the thermal and power solution of your laptop. In my case, I will use Intel XTU, but all actions are the same for throttle stop. Let's start by checking our initial settings. Default TDP is 45 watts, and CPU can consume up to 56 for a short period of time. Current CPU utilization is about 2%, and current CPU frequency is 3.9 GHz. In these conditions, CPU consumes about 20 watts, which is much lower than base 45 watts TDP. Temperature is also low, that's why we don't have thermal and power throttling. Let's simulate a high complexity workload. As we can see, CPU frequency is about 3.0 instead of 3.9, and power throttling is here, because TDP is 56, that is more than base 45 watts. But after a couple of seconds, the TDP will go down to our base 45 watts, and the CPU frequency will be even lower. Let's lower the voltage and see what happens. If your laptop has a good cooling solution like mine, you can increase your TDP limits in addition to undervolting. As you can see, the result can be really impressive. Before starting your undervolting process, I advise you to find on the internet an average undervolting value for your CPU, so you will have an understanding of what you can expect. Also, you should respect a voltage decreasing interval of 5 mV, and after each change, you need to stress test your system to assure stability. If after this manipulation your system is not stable, I advise you to increase your voltage by 10 mV. After finding a maximum stable undervolting value, you should stress test your system with a benchmark or 3D game. It's very important to stress test your system with full CPU and GPU load simultaneously. After increasing the TDP limit, you can start noting battery drain while gaming. It means that your power supply cannot provide the required power. In this case, the missing energy is taken from the battery. That's all from me now. Please leave your question and comments below and subscribe to my channel. See you!